first we shall discuss about the Venturimeter. This Venturimeter was invented by Clemens Herschel in 1887. He named this device in the honor of an early investigator, G.V. Venturi. He was an Italian philosopher. Now, this is the shape of the Venturimeter. In this Venturimeter is a device which is used for measuring the flow rate through a pipe, right. So, in this case, this is the shape of the Venturimeter, where up to this point we have a pipe, and here also we have pipe from this point onwards, right. In between, this device is known as Venturimeter. In this Venturimeter, you can see that we have three distinct portions. In first case, this area is reducing. This is known as converging passage, and here we have a minimum area from this point to this point. This is known as throat, where we have a minimum area, and then we have another area where area is continuously increasing in the downstream side. This is known as diverging portion. Then the area is achieved as equal to the diameter of the pipe, and then it is connected to pipe. So, we have a pipe of some diameter. Depending on that diameter, we have to make a device where inlet diameter is same as the outlet diameter of the pipe, and outlet diameter of the device must be equal to inlet diameter of outgoing pipe, right. Now, with the help of this kind of device, what we are doing, we are changing the area in the flow passage. When we are changing the area, then what we are doing, we are changing the combination of pressure energy and kinetic energy, because we know that pressure energy P over rho g plus V square divided by 2g. If we are assuming that we have a horizontal one, then this combination must be equal to constant. So, if somewhere we have a less area, then with the help of continuity equation we can write that A1 V1 for incompressible fluid is equal to A2 V2, right. So, if area is changed, then the V1 V2 will be changed. If V1 V2 will be changed, then this term is changed, velocity head is changed. When velocity head is changed, then P over rho g is also changed. And if this P over rho g is changed, and if this P over rho g can be measured and can be related to this velocity, and velocity multiplied by area is what? Basically discharge. So, this Venturimeter is based on simple principle. That principle is that we change the flow area. By changing the flow area, we are changing the combination of velocity and the pressure head, and pressure head can be measured with the help of differential manometer or simple piezometer tube, and by measuring the pressure head at 2 points, we can relate the velocity, and velocity multiplied by area is equal to discharge. So, with the help of this simple principle, we can develop a device. Now, if this device is like this one, where we have a converging passage, then we have a minimum area which is known as throat, then we have a diverging passage. Now, if you look at this figure, then the converging length of the convergence is very small, because this angle of the convergence is approximately 20 degree. But in case of diverging portion, we see that length is very large. It means that angle must be less. So, this angle of the divergence is generally kept 6 to 8 degree. When it is kept 6 to 8 degree, then naturally the length becomes more to achieve the same diameter.